thank you everyone for attending. I guess I'll do a brief intro as well. So Ian Cooper, I'm the CEO at SeekOps. I joined about 18 months ago now after nearly 30 years with Schlumberger. Did a variety of roles around R&D development. And then the last 12 years founded and ran their venture capital group, led the investment in GHGSat, sat on the board there, and that's where I kind of got an interest in methane emissions. I met the founders at SeekOps while I was in that position and kept in touch. And so 18 months ago came across to lead their kind of growth round, a Series B growth round, and take the technology and the company globally. So today I'm going to say a little bit very little about the company, the technology itself, and the breadth of the markets that we're in. And again, the focus here was primarily to be really the non-oil and gas side and show what we've been doing on biogas and landfill. And again, I know Carbon Mapper have also been active in some of these areas as well. So that it'll be certainly very interesting, I think, when we get to the Q&A portion to discuss some kind of shared views on how those markets can be addressed with remote monitoring. So I've got an agenda here. Again, I'll certainly touch on some of the offshore work we've done as well. Again, I think we're almost unique in doing quantification offshore today. We know that this is a complex, dynamic space with a variety of competing and complementary technologies as well. And I've always said, there's no silver bullet to emissions monitoring. There's a suite of measurements across the spatial and temporal scales needed to manage what is an inherently complex issue in what is inherently a complex flow environment, the planetary boundary layer as well. And as I said, I was an ex-meteorologist, so I've kind of come full circle when it comes to at least some of the science behind some of this as well. So the company was founded as a spin-off from NASA JPL. They took essentially what was the tunable diode laser from developed for the Mars rover, ruggedized it for oil field operations, and formally formed the company in 2017. That was Andrew Aubrey and Brendan Smith, both still here in Austin, where we moved the company a couple of years from forming it in Pasadena. Almost immediately went to work in commercial activities for the initial investor Equinor. And then subsequently, we've brought on board the Oil and Gas Climate Initiative and Schlumberger and Caterpillar as investors as well. And again, as a previous VC, having multiple corporate investors can always be a little tricky. But I think in this case, for this technology and for this market, it made perfect sense to have that kind of mix of investors. We focused very quickly on validation of the technology. So I know there's been some publications around the Stanford EDF Mobile Monitoring Challenge, and we've continued to participate where appropriate in controlled releases. I think we've participated in about 300 or 400 controlled releases. And as you'll see a little bit later on here, we're actually, one of the reasons we've just moved offices is that we've got 2 acres of land next to us and have constructed a test and training center there where we'll be actually do our own controlled releases and for test and training purposes. We've operated offshore. We performed the world's first beyond visual line of sight emissions quantification for offshore platforms in the North Sea. And then last year, or the year before now, did the world's first emissions quantification for the biogas space. And I'll get into more detail on that. And then have been doing detailed landfill monitoring and quantification of emissions recently, and I've done a number of landfill sites across the US over the last year. So the sensor itself is an open cavity for the onshore and a closed cavity for the offshore. Again, we wanted to be sensitive to the fact that we were flying fairly close to the ocean surface and didn't want to get spray into the device. So on the top right there is the device that sits under the wing of the FlyLogix fixed wing beyond visual line of sight drone. So that is a long range drone that's got about a 600-kilometer range. The technology itself is a tunable diode laser tuned specifically to methane molecules, part per billion sensitive, and where and how we measure leads to around 200 of a kilogram an hour detection threshold when it's placed on a multi-rotor drone, which, as you can imagine, can get quite close to sources, obviously outside of any explosion-proof or intrinsically safe zones. And then offshore with the fixed wing, because the fixed wing is a little bulkier, and we're certainly sensitive to the whims of the operators there in terms of staying distant, being unobtrusive to operations. We're a little further away, so the detection limit is about 2.5 kilograms an hour for that offshore. The units are self-contained. They have their own power, communications. They are very low power, so less than 2 watts complete, including the LiDAR as well that we use on the multi-rotor for height. A lot of the engineering effort that went into the commercialization of this technology is really been to put it in rugged environments, high vibration, hostile, wide temperature range environments that typically optics don't like. Again, I think one of the benefits from coming from an engineering background like that of Schlumberger is a focus on process and technology development to ensure ruggedization, consistency in the field deployment and workflows. And we provide reports, both a 24-hour report, immediate feedback. If there's a large leak, we link direct to a ground control station that will highlight a large leak. And then we typically give a quick look 24-hour notice of where we've identified problems. And then a couple of days later, a full report with detailed quantification of each of the components. We leverage very strongly the automation capabilities of those drones. So today's enterprise-grade drones have fairly sophisticated anti-collision. We've tried running it into the sides of buildings, and they will not allow themselves to be destroyed. They will self-land. We've certainly seen incidents where if we've lost a propeller, for example, they will immediately self-land. And realistically, the DJI M300 is our drone of choice, but because of that independence on power communications, we are drone agnostic. But we keep a very close look on the automation capabilities and enhanced automation capabilities of these enterprise-grade drones so that we can leverage them. Additionally, as I mentioned, we've built up and right adjacent to the office. So just in that bottom corner there where that kind of circle is, the office is just below that. We have this 2 acres of land where we've got 2 levels, so we can also test the terrain following capabilities of the drone. Very important in the landfill sector, where we can maintain constant height over the surface of what is topologically quite complex. We are also looking to put a BV loss waiver for this site so that we can actually have a remote control center for the drone and prove out the beyond visual line of sight capabilities for the multi-rotor work, which will certainly enhance kind of multi-pad capability for kind of US land operations. And then also allows us to do a number of different things. So again, I think I have a little animation showing how we cleared the land. We've left it fairly complex with a few trees in place as well, so that we can have some hazards. This is also going to be a training center for pilots. Our business model is to partner with third-party drone service providers, train them, and then essentially let them deploy the sensor on our behalf. The flight paths we have are not difficult, but they're subtle, I would say. And again, I've got an example of that coming. So again, this is the test center. It's going to have 17 release points. This was a photo from about a month ago. We've all, as you might imagine in a startup company, mucked in to help clear and set this out. We're going to have metered releases, but it really allows us to train, have videos for training, do customer demonstrations. We'd certainly love to put some long-term fixed sensors on there as well. It really is helps us accelerate technology development, but realistically, more importantly, make sure that everybody that's going to be deploying our sensor is trained to the same standard as our own pilots and really understands the subtleties of the markets in which we deploy and the complexities and lack thereof in some cases of the flights that we do. And again, continue to build out the end-to-end automated workflow so that from invoice to report, the aim is to be fully automated. And again, this is again a site that I think, you know, offline we can certainly discuss with Stanford potential ability to use as well. So we're in 4 markets today. Again, conventional oil and gas is the first of these. Traditional onshore, offshore, midstream. We've looked at and have done some test flights on P&A wells. Getting anyone to pay to look at some of the issues around P&A, frankly, has been an issue. And as a growing startup, we don't do anything for free anymore. But realistically, we'd love to certainly do a more in-depth study around the leaks from P&A wells. Again, the sensitivity of our sensor lends itself very nicely to what we would expect are smaller leaks from those kind of wells. And again, I've got a little bit more detail on onshore and offshore. We've got 4 reasons people contract us for services. Again, the obvious ones are leak detection and repair. Again, we call it leak detection and quantification as well as repair. We have partnered with a number of companies that do the downstream repair side of that contract, so that we can offer an end-to-end solution to the customer as well. For the offshore, typically the interest has been around the platform asset level top-down reporting. And again, I think there's been a number of publications that you've probably seen, particularly around the work we've done with BP on that side, to compare bottom-up and top-down, and the differences that we see behind those numbers, which can be quite interesting in some cases. I would say offshore, the leaks we've seen tend to be a little smaller, as you might expect, particularly in the North Sea, where there's been fairly long-term scrutiny around emissions. We're starting to see more interest around using our technology for responsibly sourced certified gas. We are one of the technologies listed by groups like MIQ, and obviously they have their partnership with Equitable Origin. And we just added Jennifer Stewart, one of the key advisors for Equitable Origin, to our advisory board as well, to really give us more insight into how that market will evolve. And then on the biogas landfill, and particularly where landfill sites are now also putting upgrading units for biomethane, carbon crediting continues to be an important driver in those markets. Keeping product in pipe is worth significant money to those producers. Rather than showing some schematics, and again, I'm hoping bandwidth doesn't works fine. I'll show a little video of a typical operation now. And I know Bob's certainly seen this before, but this is a fully automated survey. There's no one flying the drone here. This is a top-down view on a well pad in the Permian. We've actually got another drone above that's doing the filming. So the second drone there you see is just the shadow on the first. It's a very still day. And here we're doing orbits around, again, the wellheads here. Again, the operator was quite surprised to see how dirty his wellhead was when he saw the video here. And then this is the point of view of the drone. And again, this is all done during the using the real-time kinematics of the drone. So these have been waypoints essentially programmed in consultation with the operator on how they want their equipment groups monitored. As you can see, it moves quite quickly. It's very efficient, and certainly for us, from a leak detection, repair, and quantification perspective, it's very repeatable. Typically, when we go to an operation like this, we'll also set up high-resolution orthomosaic maps, which also enable us to, again, use things like terrain following, but also give us detailed contextual information around the equipment that's on site at that time. Again, also knowing that can evolve over time. The drones can typically fly in a light rain, heavy rain, again, because it's an open cavity sensor. We tend to get some fouling of the optics, as you might imagine. So we can certainly operate in a light rain. This is a typical data acquisition speed. And again, we're acquiring data at 10 hertz while we fly. We're actually doing it a little faster, but we downsample to 10 hertz. It's very smooth, it's very efficient, and it's very unobtrusive. These enterprise grade drones are they're louder than you might get from Best Buy, but they're still really not very obtrusive at all from a noise pollution perspective either. One of the biggest issues we thought about from the biogas sector is, would it spook the correct cows? And cows being cows kind of look up once, wonder what it is, and then go back to eating. So what comes out of that is a map like this and a report like this, where we'll highlight, the variation in the wind, the enhancements that we've seen around those equipment groups. Again, typically the operator is wanting to have the equipment grouped together. On a good day, we might be able to find a leak from an individual component, particularly if it's something like a thief hatch left open, or a very obvious leak from a separator or a wellhead. But typically we group it by equipment group. And again, depending where we are, we'll give it in standard cubic feet per hour or kilograms per hour. We don't overfly any equipment. Again, one of the benefits of the drones are that we can make sure that we don't overfly equipment or personnel. We typically take a measurement of the background. As you might imagine on a biogas site or an oil and gas site, you do have an elevated background. And so we're looking, again, because of that part per billion sensitivity, we're looking at enhancements above the background then. And so we fly, whether it's downwind curtain patterned interlaced curtains or orbitals at interlaced heights, and we can get the high resolution curtains around the equipment by which we can ascertain and triangulate essentially where the leak is coming from, and then convert that to the leak rate with the wind. Right now we have an anemometer on location, but we're starting to use wind on drone measurements as well. As you can imagine, having essentially GPS, wind, and concentration on location helps refine that uncertainty even more. Occasionally we will revert to manual mode, particularly if we've got widely ranging wind directions, if it's certainly changing significantly during the acquisition time. And that's for a site like this, typically to set up, do the orthomosaic imaging, and then do the survey setup and survey is about an hour. When we go back, and again, I've got some results of a resurvey here. When you go back, it's about 5 to 7 minutes push button to repeat that survey, because again, it's fully automated. We've been approved now by the Alberta regulators as an alternative emissions, as part of an alternative emissions monitoring program. So, which means essentially no OGI follow-up would be necessary, and that our results would be essentially acceptable for the regulator there, which I think is a big step forward for any of these new technologies. And we're hoping that there'll be more technologies recognized around this space. But it says emissions limitation in the EPA equivalent of that. We know EPA is kind of on hold while they're looking at the new regulations, but emissions limitation is not straightforward. So we had a Permian independent operator have us fly an automated repeat survey after they effected the repairs. And again, it took 3 months for the repairs. And as an operator, they've been very open. We actually have a paper accepted for the SPA-TCE, where we'll talk in more depth about the workflow and the subsequent events here. But in most cases, the repairs were effective well, and so we did see a significant decrease in emissions, as you can see on the table here. But in some cases, when we went back, we saw significant enhancements as well. And we typically take detailed field notes. We know that contextual information and ultimately that unstructured data for things like machine learning will be important. So we recommend and train our pilots to take copious notes with keywords. And it was subsequently confirmed by the operators, yes, they had unlit flares on 2 of those sites. And again, there's a number of studies going on now looking at flare efficiency. And so context is everything. You can fix the repair, but if you don't like the flare, then your emissions could well be higher. So that operational context is really important, particularly on the land operations we've seen. If we move offshore now, again, we've got 2 approaches. The first has been what we've published a number of times on the fixed wing. This is the beyond visual line of sight, typically launched from shore, goes to the offshore platform, performs what I call kind of the beehive model. So we encompass the emissions around the platform with that fixed wing plane, spends about an hour on location, and then flies back. Again, about a 600-kilometer round trip time. Most of the work to date has been in the North Sea. I think we've done 6 operators, about just under 20 flights to date there. We've already got scheduled about 120 flights this year, so that's rapidly growing and beyond the North Sea now. So we see this as being a very useful technology for that asset level. But of course, people typically want more information than that. So we've also been working on the deployment of the multi-rotor drones, obviously much closer. In a post-COVID world, it's much more difficult to get onto a platform unless you're truly revenue generating. So we've looked at deploying from supply boats. There are some operators that still would like deployment from the platform itself. And certainly you can envisage drone resident systems being a kind of one of the long-term approaches here, particularly triggered by fixed or IoT sensors as well. This case, we're doing it line of sight. It's launched from the supply boat. And here we can get a bit more granularity on potential leaks, locations, and in some cases, emissions above and below the deck level of the platform, which is quite interesting for things like cold vents as well. Again, we've done this globally. And I think the more operators we talk to, the more they're starting to get comfortable with drones in the offshore environment, close to platforms. So renewable natural gas is the other, I would say, second of the key markets that we've seen rapid growth in, and again, certainly sales cycles have been a lot shorter in the renewable natural gas market compared to oil and gas. What to me has been interesting here is that almost every part of their value chain has been leaking, and the regulatory thrusts have been perhaps not as focused on this area as they have in oil and gas and even landfill side. And that was one of the reasons we reached out and wanted Harman Decker, the head of the EBA, the European Biogas Association, to really help us understand this market and its evolution. And certainly post Ukraine invasion, we're certainly with potential supply restrictions in the EU, we've seen even faster growth and acceleration in wanting to build more biogas facilities. So biogas, biomethane. So you may hear them used interchangeably. Biomethane is effectively upgraded biogas. Biogas is typically 50-50 mix there or thereabouts of CO2 and methane with a few other species. As you might expect, it comes from a range of organic matter, whether it's solid waste. We've done a lot of work on dairy farms. You can imagine wastewater as well. Typically, these go into an anaerobic digester, again, whether that's a concreted area where the sludge is stirred and the gas taken off of that, or these dome type digesters. And then the processed weight is typically put into a pond. And what's been interesting is when we've surveyed that processed digestate, it's still emitting methane. And so you've almost got a measure of the efficiency of your digestion process with that. Upgrading will typically strip out things like H2S and some of the other non-desirables. CO2 is handled there as well. And then typically it's either used for combined heat and power locally, or again, upgraded, cleaned and put into the grid, or for transportation. It's a rapidly growing area. The kind of circular economy around the use of that organic matter has certainly been in discussion for a while. I would say Europe is slightly ahead of the US, and I've got a little kind of comparison on the markets here. Right now, there's about 2,300 operational biogas systems in the US, but there's rapid growth expected and being funded. Companies like Brightmark have had significant investment from Chevron. Most of the major operators, as you might understand, are certainly kind of experimenting or getting into this market fairly aggressively. And so it's really another string to their bow in terms of access to gas, but also access to the carbon credits that come with that as well. So by 2030, there's expected to be 15,000 biogas sites across the US, and almost, I think, every state will have one. Again, the drivers here, as you might imagine, are more on the credit side, the low carbon fuel standards. The product value is very high. And so in terms of its carbon intensity, obviously, as you can see from the graph here, renewable natural gas, particularly from manure, is very attractive. and can certainly, you're looking at maybe 10 to, in some cases, 100 times the spot price of the natural gas itself in terms of the value of the credit. So again, keeping product in pipe is incredibly valuable to any of the biogas producers. And they've previously done very little in terms of monitoring, whether it's optical gas imaging cameras, or just ensuring that the construction is built to certain emission standards. And certainly, discussions we've had that post commissioning of any system now, emissions are going to be a key part of that commissioning. One, because any repairs can also be affected under warranty. So emissions, you'll see, I think, will be an important part of construction of these markets, but will also be assessed across that whole chain, including things like the process digestate and ultimately how that's handled. On the EU side, they've certainly had a bit of a head start. There's about 19,000 biogas plants. I think it's 11,000 in Germany alone. And again, discussions that we've heard around the biogas growth is that they're going to continue to build around here. And expectations are that up to 40% of the total gas consumption will be biogas in the EU by 2050. So again, this is a rapidly growing and important market, and an important contributor in terms of emissions as well. So a typical biogas facility, again, we do the same kind of approach: high resolution ultramosaic images, and then we look at the components. Obviously, the components are a little different. There's the pre-processing side. There's the digester. In this case, in this image, this is a concrete digester. So that's this part over here. It's a flat concrete surface where, I guess, for want of a better word, the poop is mixed underneath, and the gas is then taken off, taken over to the gas upgrade system over here, and then the effluent is separated and put out into a pond here, which also emits methane quite significantly. Interesting, in this case, we actually found one of the leaks was downstream of the flow meter. So, what they thought they were getting wasn't what they were actually getting. And again, with the drone, you can get quite high resolution here. This is a fairly small site, but not atypical for a biogas facility in the US. Again, biogas ideally suited to drones. I think I've got a little video here that shows how we go. Again, we leverage the automation. Again, all this is done in coordination with the operator here. Safety is paramount. So, the first part of the day is all about the safety briefing, particularly on these kind of sites that maybe haven't had the same kind of scrutiny or level of safety focus that maybe oil and gas has had in the past. We've done a number of sites now, US, EU. Again, everyone is slightly different here. You get, certainly it's less cookie cutter compared to a set of well pads in the Permian, for example. Typically, again, it's leak rate, leak location they're wanting here. And in one case, we actually had to stop them following us around with a wrench to try and fix things behind us as we spotted the leaks, just so that we could get at least that site level quantification. The rates tend to be a little lower. I think the leak on this site was about 50 scuffs per minute. So again, not insignificant, but certainly smaller than typical oil and gas large-scale operations from oil and gas. As I mentioned, we get leaks from almost every part of the process. So here again, this is a concrete digester. What happens is you tend to get methane that bubbles up underneath the concrete. And so you get these little blisters, and then the gas comes out right there. And so we've highlighted again some of the leaks here with the kind of orange flares coming out of those blistered leaks that we've seen here. In this case, again, with a hot zone approval, we actually went in very close, took the sensor off the drone, used it in handheld mode. Again, important to get that hot zone waiver. It's a very low powered enclosed device, but it is not intrinsically safe. But again, the operator felt comfortable enough going and letting us effectively wand some of these issues. So again, we saw the H2S scrubber leak, many hoses and flanges, and again, their expectations were dashed, frankly, and we found the leaks were about 8 times higher than they were thinking. And again, broadly across that whole workflow as well. Again, not insignificant. This is another example where, again, the effluent itself was only just below that of the biodigester in terms of leaks. So again, the leaks here in the orders of hundreds of scuffs per hour. Again, if you compare that, these are the kind of leaks that you'd certainly see by satellite as well. So pretty significant. So moving to the landfill side now, again, as you might imagine, this is a very complex topography, topology. It's evolving continuously. Typically, this is kind of a schematic of a modern landfill design, certainly the type we've flown in the US. What's important to note here is you've got essentially 2 stages. You've got the waste in place that's been buried, where they've put gas collection wells in place. Certainly these collection wells are numerous. They're different locations, different heights. And then you've got the active burial region, which certainly changes daily. It is truly ever changing. We did some work in a landfill not too far from here where we are, and trucks are coming from dawn till dusk. They're continually looking at trying to bury the landfill, and so you've got these different rates of burial, different ages of the buried material, which leads to an evolution across the landfill site in terms of the leak rates. So the traditional survey today for a landfill site is a walking survey. So this is someone with a handheld sensor that walks a few inches above the surface. The grass has to be mown. As you can see from that image, it's not the most lawnmower friendly. It's expensive for a site that's a few hundred acres, and with that level of complexity with gas collection wells at regular locations to mow. Clearly, one of the benefits of a drone is one, you're not employing someone to do what is effectively a fairly nasty job. 2, you don't have to mow the grass. 3, you can get very close to the collection wells, again, with the sensitivity of our sensor. So, and you can also, again, leverage the terrain following modes of these drones to, again, automate the process. On this particular site, the one area we actually had to fly manual was there were some trees near the entrance to the site. From an aesthetic point of view, and again, we just didn't feel comfortable setting a drone that would go over the car park, so we flew it manually, essentially behind the trees. And also, again, as in the oil and gas side, facilitates those repeat visits. And again, we've had conversations around the landfill site. Is ideally where they'd love to evolve is drone in a barn, be able to deploy daily. And we've even seen diurnal cycles, depending on the rate of active burial on these locations. What's also interesting now here on the landfill side is many of these landfill operators are looking to, essentially harness the product that they have within the landfill. So they'll be looking at putting upgrading units on these facilities, very similar to biogas, and producing biomethane from that. We did 2 types of survey here. So that mesh that you see on the bottom there, each of those yellow pins is a location of a gas collection well. And we flew this complex mesh pattern here. And then we did some long curtains around it. And the total asset, as well as summing up the individuals around each of those grids, was less than 5% difference, which 1 gave us a lot of confidence in the measurement. And 2 gave us a real sense that there's value in those individual measurements, because we could certainly identify individual leaks coming from those gas collection systems as well. What's really interesting is just how big these are. And again, for those of you that have seen the kind of focused on landfill, 2021 Biden released that he wants to really get after reduction of landfill emissions by 70%. Here we compare on the graph here the recent landfill site we did a couple of weeks ago, and the emissions here again in kilograms an hour. Apologies for switching units on you. Compare it to 4 offshore platforms that we did, typical offshore platforms in terms of their emissions rate, 5 onshore processing facilities, and then 10 well pads. And again, most, you would say, we're in the kind of 200 to 300 kilograms an hour range here. Your order of magnitude more. And again, the bulk of this is from the active burial region. So again, it's a significant contributor. I think not necessarily surprising to the landfill owners, particularly I think given some of the measurements they've done in the past. But I think quite interesting in terms of, you know, where they take this moving forward to try and reduce that 70%, because even a reduction by 70% is still not necessarily going to get you where you want to be. So again, we see this as a very exciting, interesting area for us. We feel that this is an area that, again, drone technology lends itself to very nicely. Certainly the advancements in things like beyond visual line of sight, I think, will be very useful for again, the automation, repeat visits. Again, everybody wants to make sure their emissions are trending in the right direction. That means, you know, regular repeat visits. I think, you know, there's a lot of discussion around the use of perimeter sensors, fixed sensors, IoT sensors. Yeah, emissions are inherently three-dimensional. I think there's certainly a role for those sensors. You know, is there a role for those sensors in quantification? That's a complex problem. I know it's one that Stanford has and is, you know, continuing to look at, as are many other companies. Certainly having the mobility of a drone, and particularly, you know, longer term, you know, drone on demand, will be, I think, very useful in really understanding and getting to what is, I think, a very complex problem. And again, I think, as I've highlighted, you know, there's no silver bullet here. There's a group of technologies that really need to work harmoniously across the spatial and temporal scales to really address this problem. Again, you know, they all have their strengths and limitations. You know, we typically have a 45-minute flight time before we have to deploy a battery. You know, even though we can deploy on cloudy days, you know, we don't like heavy rain. We know fixed sensors have problems with fouling in sandy conditions. So again, you know, leveraging the strengths, but also understanding the limitations of these technologies, I think, you know, enable us to work together to address the problem. So again, in summary, I think drones have proven themselves now very useful, both fixed wing and multi-rotor for onshore and offshore industrial facilities. And again, I've not just said oil and gas there. We can do direct measurements close to the source, and again, it's really as close as you're comfortable, or as close as safe. Again, safety is the #1 concern. Of course, we see large leaks, but I think, you know, where we've been targeting and what we've highlighted are those more insidious, difficult to access or difficult to identify. You know, where we've done follow-up with optical gas imaging camera, even a trained, seasoned OGI operator has sometimes struggled unless they get in exactly the right position to see some of these leaks. And these are the leaks that can go unnoticed for years. And, you know, when you've got, you know, 100,000 of these, that's a significant contributor. So, you know, while the story is, you know, big leaks contribute to the bulk of emissions, once those are found and fixed, you've got to find the small ones as well. You know, we have seen swift and targeted remedial action. Again, one of our cases, the well pad was actually rained out, so they couldn't get out there for months and ago without fixing these leaks. So again, operational context, really important. We continue to understand the 3D nature of these emissions. Again, as a kind of atmospheric scientist, planetary boundary layer is very complex. You've got convection currents, you've got heat and moisture fluxes that can all contribute to the plume dynamics. You've got vortex shedding around some of these equipment. So being able to encompass the plume can be quite tricky. And again, a drone gives you that ability above and beyond a fixed sensor to really address that inherent 3D nature of the emissions. Again, we want to move towards totally unmanned and remote operations. I think it was just earlier this week, both Amazon, Walmart got BVLOS permission for last mile delivery. You know, they're going to drive the technology even further, even safer. And, you know, we certainly will be leveraging that. You know, there's a number of drone in a box providers out there now. We're already starting to talk to a number of them for resident and hosted systems. Clearly, a resident system to me is it's a mobile fixed sensor. Continuing to respect the safety of operations and translating that safety and safety learnings to some of these other verticals, I think is going to be critical, as is the comfort level with drone technology in general. There's still, I would say, a little reticence among some people that to use drones, whether they see it as the spying policeman or they just feel uncomfortable with them in general. Everybody wants accurate temporal emissions. They want to be sure, you can't get to net zero without having a curve that's trending in the right direction, which means repeated measurements are at a certain frequency. Continuous is an ideal. I think we'd all love continuous three-dimensional measurements of emissions. There's a trade-off with complexity, cost there as well. We have Schlumberger as an investor. Their software is in almost every operator office. It makes sense when you're putting emissions in the context of other operations to put it where data is resident, and so that's certainly one avenue that we've gone down. We are starting to see almost more pressure around certification for responsibly sourced gas than regulatory, which is, I think, an interesting dynamic and certainly something that's only changed recently. Biogas landfill, I think you have clearly highlighted the suitability of drones in those markets and the value they can bring, particularly, again, ensuring product is kept in pipe, repairs are effected quickly. We haven't done any mining sector work yet, but we're in discussions to doing some. Some of the mines are significantly larger, but also I think, as we've seen from satellite, some of the emissions are also significant there too. And so, again, things like BV loss for fixed wing drones could be very useful for that kind of deployment, particularly in some of the remote regions, as you might imagine in Western Australia, for example. So with that, I think I wanted to leave some time for questions. I think I had just a title slide at the end there. Again, the sensor itself is about 6 inches long. It's 600 grams, so it's very light. Again, if we were to make that truly intrinsically safe, it would add a lot of bulk and weight to it. But yeah, we've certainly seen the value in using it in a handheld mode with the appropriate waivers. And with that, I'll open up to questions.